Ladies and gentlemen, let's observe the diagram. The diagram shows that a coin in a magnetic field, in a permanent magnetic field, and then the type of connector here are the slip rings. So this means that this is an AC generator. So AC generator, the AC generator, that means that when it's turning, it will generate the electric current, the AC current. So now we look at here. When the motion is slow, that means that the electric will be generated. Okay, so from here, what we can observe that the direction, what's that? The deflection of the pointer. The pointer will be go to left a while, left side, right side, and left right. So that means that it will, the direction of the current always change, keep on changing. Ladies and gentlemen, now we look at here. When the direction of the current change, it means that the current always change. That means that flow in flow and reverse direction. So from here, this we call that this is a alternating current. Ladies and gentlemen, how about if the motion change faster? When the motion change faster, we notice that the speed of deflection increase. The bulb also light up. Actually, it's light up and light up, light off, light up, light off alternately. But due to the due to the change of the amplitude, so it's light up again. What happened if we change to very fast? If we change the speed to very fast motion of the coin, very fast motion of the coin to cut the, to cut the magnetic field. So we notice that the bulb light up almost constantly. Not only constantly, but we notice that the please observe the angle of deflection. The angle of deflection show that almost none of the motion, none of change, right? All the deflection are very, very small, almost stable. Okay, so let's see how is the sandwich maker. Sandwich maker, for example, is like that. Behind, we notice that there is 240 watt and 50 hertz. Why the alternating current got the frequency? The frequency show that there is the rate of change of the direction. Just now we notice that. Okay, we notice that the direction always change, right? So this means that, as I mentioned before, the current flow to one direction and back to one direction. So this means that we need to know how fast it's changed. So the frequency for the alternating current used is 50 hertz. 50 times change in 1 second. Ladies and gentlemen, okay, loading again. Hopefully nothing happened. Okay, ladies and gentlemen, let's observe the diagram. We connect two wire to the what's to say that frequency AC generator. So that means AC generator, that means this device will generate the alternating current, where we can make sure we can generate according to the frequency we want, variable frequency. Because if we directly connect the current we use, okay, from the power socket, so the frequency is 50 Hertz. So we connect the current. Alternating current do not have any positive terminal or negative terminal. Okay, so that is the characteristic of the alternating current. Alternating current flow through a resistor, and there will be a connector X and Y here. We need to connect the ammeter. Either we use the center ammeter or we use the normal ammeter. Let's look at we use the center zero ammeter. We notice that the direction, okay, it will change direction, move forward, the pointer move to right, then move to left, then back to right again, left, right motion. What happens if I replace it by the non-center pointer, non-center zero? That means that if this meter able to make sure the alternating current show that actually just now we noticed that how much, 3 something, right? But now just 2 point something, 2 plus something, less than 3. Okay, that means that we notice that from here the maximum value is 3 watt. Maximum value is 3 watt. Okay, left and right confirm that is 3 watt. But what happened is when I replace with a non-zero ammeter, non-zero, okay, non-center zero ammeter, we notice that it's around 2 plus only. Why? This is what we will learn. Okay, that is the first objective we will learn. Okay, so now we go to the next slide. Okay, ladies and gentlemen, let's look at the diagram. The diagram show that two of the heater. So the heater, immersed heater, is used to heat up the same amount of water, starting with the same temperature and so on. The difference is one use DC source, DC current. That means that use battery with DC current. This one use the AC current, alternating current. Consider both of them with the same, same voltage. If this one 10 voltage, 10 watt, this one also 10 watt. Yeah. So what happened when we switch on? When the time is going on, we notice that the current, current flow is almost at the zero. Okay, if we make sure by using the normal ammeter, we notice that it's forward. This one also forward. But for zero, for center, zero center, show that it is 4 ampere. So this one 0. But alternating current show that the source of the alternating current is like that. For the direct current show that the output is a straight line. Okay, let's look at the next diagram. Okay, now look at the diagram. The diagram shows that there will be a sinusoidal wave pattern, which is 2.8 cm from the center, from the equilibrium line. That means that equilibrium is at a zero, yeah? So from here, the direct current shows that there is 2 cm from the equilibrium. So that means that if the scale we set 6 watt per cm, if there is 6 watt per cm, that means that this is 2.8 cm. 2.8 times 6 is how much? 2.8 times 6 watt. We get that it will be 16.8 watt. Here 16.8. But when we use a DC, we notice that how much is it? It's just 6 times 2, that is 12. 12 watt and 16.8 watt. But the reading we just now we supply both of them supply with the same voltage, right? Let's say there is 16, okay, 16 watt DC and the 16, okay, 16 watt of AC. So that means that this shows that there are some difference. Okay. Okay, so now what actually happened in the circuit, in the AC and DC circuit? Ladies and gentlemen, we observe that when just now we notice that the current, okay, the current flow, one is 4 ampere for the direct current, and it shows that it's like that. 1, 2 scale only, right? But this one show that more than 2 scale. That means that the voltage supply a little bit higher, but this one, okay, direct current is a constant and stable current. Now observe that the difference. This one actually we use to show the direction. The direction show that the current flow to right side. This one at center. Why? Because it show that it's always move left, right. Because of the frequency 50 hertz is very, very fast. So what we can do, okay, is show that it almost vibrate at the center. Then what happens if we stop? Okay, once stop, everything will go to zero. Okay, so that means that when starting, so it will move until stable for the ammeter from starting from zero. But just the difference will be the ammeter here and the output signal. Let's go to the next slide. Okay, so next slide, the definition of the RMS value. What is meant by RMF? RMF means that is root mean square. Okay, ROOT, root means 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 square, SQUARE. Root means square. So what is mean by root means square value? The RMS or effective value of an alternating current in the value of steady current, which would dissipate the same power in the resistor. Okay, that means that the RMS or the effective value of an alternating potential difference. If RMS value for alternating current, okay, root mean square for the current, that means that that is the current which is effective. Alternating current, not a stable current. Okay, so let's say if I use a battery of 5 volt, that means that the effective voltage, the effective current, the effective voltage will be 5 watt for the direct current. But if I use for the alternating current, if I use 5 watt of the alternating current, actually just okay around 4 watt only, or less than, easiest we said that less than 4 watt will less than 5 watt will be the effective. So what happens actually from here, we can set that the RMS value will be the effective value of alternating current. Okay, effective value of the alternating current. So from here, let's say, okay, let me write something. Okay, let's go to the slide. If there is an AC with time, if this is AC of 5 watt, so this will be a stable, always 5 watt. But if we use an alternating current for 5 watt and -5, if I use the alternating current like that, that means that actually, okay, actually is it when I convert it to a value of steady, okay, because alternating current with positive and negative, right?